We are looking at question number 8. The question says, this question is about the reaction between hydrogen sulfide and oxygen. And they've given us the equation for the reaction. And if you look at it carefully, they've also given you the states involved for the reactants as well as products. Both the reactants as well as products are in the gaseous state. First part says, what does H2O represents? All we have to say is, because it's a gas, we'll say this represents steam. The next part says, calculate the volume of oxygen required to react with 50 centimeter cube of hydrogen sulfide. Now in this case, all reactants as well as products are in the gaseous state. So you have to remind yourself that mole ratio is same as volume ratio. So considering this information, I can then say that when I have H2S ratio O2, according to equation, these are 2 moles and these are 3 moles. Like I said here, mole ratio is same as the volume ratio. So I can say this is 2 centimeter cube and this is 3 centimeter cube. Now the question says you have been given 50 centimeter cube of hydrogen sulfide. So under hydrogen sulfide, I'll write down 50 centimeter cube. I don't know how much oxygen will be needed, so I'll say X centimeter cube. Now you can cross multiply them and equate, and you will end up with your answer once you have solved that expression. So it will become 2 times X equals 50 times by 3. You divide both sides by 2. This cancels out, leaving you with X being 75 centimeter cube. The next part says, figure 6 shows part of the reaction profile for the reaction. The reaction is exothermic. Now remind yourself, exothermic means energy is given out. My products will have energy less than the reactants. The question says, complete figure 6. So they've given us energy profile diagram. It says you should complete the profile line. So that's 1. Label the activation energy, label the overall energy change. Now I've already been given information that the reaction is exothermic. So this means my products will have energy which will be less than the reactant. So I'm going to say these are my products. I'm not going to use word products. It should be a horizontal line here. Now for products, I'll have to go back to equation. In my equation, my products are H2O gas and SO2 in the form of gas. So I'll write down 2H2O steam plus 2SO2 gas. So I've done the first part. Now it says label the activation energy. Remind yourself, activation energy is the minimum energy required for the reaction to start. So in this case, this is my EA. So we've done this part as well. Last part says label the overall energy change. The overall energy change is the difference between the energy of the reactants and the product. So this is the total amount of energy that my reactants had. This is the total amount of energy that my products have now. And this is the difference. So this is what we say delta H. The last part of the question says figure 7 shows the displayed formula equation for the reaction of hydrogen sulfide with oxygen. So we've been given displayed formula equation, and we can make use of this displayed formula equation to work out the amount of covalent bonds and their type on the reactant side as well as on the product side. Here it says table 5 shows some of the bond energies. This table is basically telling us the amount of energy that we will need to supply for breaking each type of bond. It says in the reaction, the energy released forming new bonds is 1034 kilojoules per mole, greater than the energy needed to break existing bonds. This statement is really important to understand. I can write it down in an understandable format. So this is saying that energy supplied for breaking bonds plus 1034 is equal to energy released from bond formation. Let's work out the total amount of energy supplied for breaking bonds. So first I will count the amount of each type of bonds available on the reactant side as well as on the product side. So if I look at this equation, I can see here in one molecule there are two S-H bonds, but there are two molecules of this. So in other words, I can say there are four of them. So I'll write down 4 times H-S plus, in this case, in a molecule of oxygen, you only have one double bond between oxygen and oxygen. And there are 3 molecules of oxygen. So I'll write down 3 times O double bond O plus 1034 will be equal to, let's go on to the formation side. So I can see on the formation side, in one molecule of water, there are 2 OH bonds. There are 2 molecules of this. So I will write down 4 times H-O plus 4 times S double bond O. Why am I writing 4 times S double bond O? In one molecule of SO2, there are 2 double bonds between sulfur and oxygen. One here, one here. There are 2 molecules, so in total there will be 4 bonds. Once I've done this, all I have to do is I just have to plug in the values from this table and I'll solve and I'll end up with my answer. So here I can say it will be 4 times 364 plus 3 times 498 plus 1034 equals 4 times 464 plus 4 times x. If you add numbers on the left side, you will end up with 3984 equals 1856 plus 4x. You have to get rid of 1856, so you'll do minus 1856 minus 1856. This will cancel out. It leaves me with 2128 equals 4x. You divide both sides by 4 and you'll end up with an answer of 532 kilojoules per mole is equal to x.